Okay, for the first part of this question, we're asked to use the formula for r squared and r to show that this sum that we're given in the question can be written in the way shown below. So the first thing we need to do is expand that bracket. Okay, now we're ready to sub in our r squared and r formulas that would give us the following. So the first thing I'd always do at that stage is get rid of, combine the constants. So for example, we've got 3 lots of 1/6 here, which we can make as 1/2. Okay, the next thing to always do is look at what the form that you're trying to get it in. So you can see here the halves disappeared, so I'm not going to take the half outside. What I'm going to do is I'm going to factor out an n from each term and an n plus 1. So just to recap what I've done there, I've taken out an n from both terms. It's gone there. And I've taken out an n plus 1 from both terms. It's left me with this. Then, because we're factorising, what would I times n plus 1 by to have got this full first term? Well, there was a half left over and a 2n plus 1, so I'll put that inside the bracket. Then for the final term, the n and the n plus 1 are already there, so I just had to have put the extra half inside. So I've expanded this bracket here, so a half of 2n is n, and a half of 1 is a half. And then neaten that up, finally you'll see, which then hopefully you can now see is nicely what we want, n bracket n plus 1 all squared. Okay, so for the second part, it says the lowest integer for which Sn is greater than 100,000 is denoted by n. Show that. It's only 1 mark question, there's not going to be much to it. Basically, what is going on here is we're saying when small n equals big N, then we know that the sum is greater than 100,000. So combining these two results together and putting them into this from the first part, we'd get, therefore n bracket n plus 1 all squared is greater than 100,000, and so you can see all we're doing now is expanding that to get the inequality above. So just to recap a bit what we've done there, in terms of the question, big N is basically the smallest integer, the smallest top value for our sum. That basically, if we added up all those terms in that sequence, n is the smallest value of terms that we add that would give us a sum greater than 100,000. So what the final part's asking us to do is asking us to find that lowest integer for n, that when we sub it into here we get it greater than 0. And it's not that obvious because we've got this minus 100,000. It's not like a polynomials question where we can guess an initial root, sub it in and solve it. What I'd advise you to do with this is just pick a number, sub it in and just use trial and improvement. And what we're looking for really is a change of sign, and if you've done numerical methods at FP1 now, you'll understand how that links together. If not, it's quite self-explanatory anyway. So let's think of a number, sub it in, see what we get and go from there. Okay, I put 50 in and you can see that's not a bad starting point. We're still at 30,050, so I'm going to drop down and I'll try 49. So we're heading in the right direction, let's try 48. It's dropping but not quite as fast as I'd like, so I'm going to drop down to 45, see what that gets me. Okay, so 45 gives me a negative value, so that wouldn't be a solution, so let's jump one back up and look at 46 and hope that gives us that change in sign. Okay, so that gives me that positive value, and because we've shown that 45 gives a negative, I know that 46 is the smallest integer value for n that would give the solution greater than 0. Therefore, I'll just finally state that capital N equals 46. Okay, and there we go. And the justifying the answer part, I've shown that with this trial and improvement. Justifying your answer is kind of suggestive that it's happy to accept a trial and improvement method. It's not saying hence, it's not saying evaluate, it's not saying prove, it's justifying your answer. I've justified that because 45 gives me a negative and 46 gives me a positive, that the lowest integer is 46 that solves this inequality. Justified.